This is a big idea in this one, so make sure you have read this opening paragraph and understand exactly what it's talking about. There's two types of concepts here: permutations, where the order of letters matters, and combinations, where the order of letters does not matter. A permutation might be something like a garage code, where you have to type that code in, not only the right numbers, but in the right order. Whereas a combination might be a combination of astronauts on a spaceship. It doesn't matter whether they sit left to right or right to left. All that matters is who's on the ship. So we're going to talk about these three situations here. Okay? And for each one, I want you to think about 4 letters chosen from a bank of 6 possible letters. R will be the number of letters total. N will be how many letters I have to choose from. So if repeats are allowed and I have to fill 4 slots, the first slot can have 6 letters. The second slot can have 6 letters. All of these slots can have 6 letters because repeats are fine. And the number of permutations possible is 6 to the 4th power. Now we've got a formula for this. It's pretty easy, and really you don't need to memorize the formula, but you can if you want. It's just n to the r power. Okay, that's the number of permutations possible if repeats are allowed. Now in the next one, I have 4 possible letters, 6 possible choices for the first one. The second one, because I don't want to repeat whatever that first letter was, only has 5 letters left to choose from. The third one only has 4 letters left to choose from. And that fourth letter, because I don't want to pick the same letter as those first 3, I can only choose 3 more letters. So when you multiply these all together, you get the number of permutations in the case where repeats are not allowed. Okay, that's an important distinction. There's a formula for this one too. Go ahead, jot down what 6 times 5 times 4 times 3 is. Watch what happens next. The formula for this guy is n factorial divided by n minus r factorial. Okay? And if I were to spell out what that is, so n factorial is 6 times 5 times 4 times 3 times 2 times 1. And n minus r, 6 minus 4, that's just 2, but 2 factorial is 2 times 1. So you see the 1's cross out and the 2's cross out, and there we go. We're left with that 6 times 5 times 4 times 3 again. So that formula is a useful thing to remember. Although, if you don't love these formulas I'm writing down, you don't need them. You just need to remember what permutations mean and the difference between repeats and not repeats, and you can multiply them together yourself. Now, this last one, the combination, I strongly recommend you use the formula. Okay, this is the only one where I would really consider it a very good idea to remember this thing. So I'm not going to go through the reasoning. That would take a little while. But suffice to say, when the order does not matter and ABC is considered the same as CBA, there's going to be less possible choices, right? Because some of those choices are considered repeats. So the formula here is going to be very similar to the formula above it. You're still going to have n factorial on top, n minus r factorial on bottom. You just need to divide it by another number so that you don't have as many permutations. Here we only care about combinations. And the adjustments that we're going to divide by is another r factorial. To explain why that's happening would take a little while. I would suggest just memorizing that formula, practice a few times, and I'll show you what that would be in this particular example with these numbers. This would be 6 factorial divided by 4 factorial, 2 factorial. Okay, so if I want to spell that out, it's going to be 6 times 5 times 4 times 3 times 2 times 1 divided by, well, 2 factorial is easy, that's just 2 times 1. And 4 factorial is pretty easy too, that's just 4 times 3 times 2 times 1. Okay, so the 2 times 1 crosses out, the 4 crosses out, the 3 times 2 crosses out with the 6. In the end, what I have for this thing is 15 possible combinations. And if you want to sit there and count up all the different combinations you can make with the letters A, B, C, D, E, F, not repeating anything and not caring about the order, you will get 15. Okay, this is a really good formula. It could save you a ton of time. I really recommend it.